Okay, welcome to the final section. I'm Jono, this is Lewis, and David. So I'll start with you, Lewis. You sort of represented the learner in this course so far. Let's see if you've learned anything. What's the course about?
The course is really about building models and doing predictions using big data sets. So what we really wanted the learners to get out of this was to be able to take a data set, wrangle it into a usable form, think about what predictors they should put into their models, and then actually train those models and validate them by doing some testing and making some predictions and validating those models. But as you're the token statistician in the room, I should ask you, what were some of the models that we were using to make those predictions?
Cool. They come back into two sorts. The first one was that simple linear regression model, fitting straight lines and adapting that to take more predictors, more fancy response variables. The second half was all about classification, trying to predict which group something lies in by using the predictors.
And why do we do this whole course using R specifically?
Okay, bit of a rant. R is just fantastic. It's free. Just start with that. But it's also the software, the program, the community that professional data scientists, statisticians are using all the time. It is just a fantastic piece to work with. It's very adaptable and it's developing all the time. Since I've started, we've had things like R Studio, R Markdown, Shiny apps, things that you can do to take your data, find the patterns and communicate that to a general audience. Now, obviously, in this course, we've been looking at big data, but you're the expert, David. What is it about big data that's so interesting?
Well, big data is both challenging and giving opportunities. The challenges, of course, is that it can bring your laptop easily to its knees. And we looked at some ways of ameliorating that, some ways of getting access to parallel computing, such as Sparkly R and H2O, etc. On the flip side, it offers huge opportunities. We're building models that are immensely complex, up to 1 million parameters. Just think of that, up to 1 million parameters. And the opportunities that those deep learning models can provide for doing applications such as speech recognition, image recognition, the things that Google and other companies are putting into their smart assistants. That's the opportunities in this area. But of course, like everything, it sounds good, but what can go wrong, Lewis?
Well, I mean, you know, 1 million parameters is great if you've got more than 1 million pieces of data or 1 million rows of in your data frame to look at. But one of the issues that can happen, particularly if you've got smaller data sets or a very complicated model, is this issue of overfitting. So where you perfectly describe the training data set, but you've got no actual predictive power at all over the new data sets. That's one thing. There's also this issue of model selection. And just because you've built the best model and you've selected the best model out of a range of models, doesn't mean you've necessarily built a good model. So these are the things that you have to worry about. So Jono, what's next for the learners?
Well, as I've said along the way, really you don't understand something until you can implement it, until you can do it. So what we're going to do is we're going to give them a chance to do them two sorts of prediction, the simple linear regression and the classification. So we're going to have one assignment where we're going to start off with simple linear regression and build it up, predictors, response variables, stuff like that. Another one, again, we're going to have something, they're going to have to do some classification and again, start small, build it up bit by bit. So we're going to have a couple of data sets that we're going to have a look at. And talking about them data sets, David, why do we choose these data sets?
Well, it's a compromise. We want some data sets that are rich enough, interesting enough, complicated enough, many thousands of items and lots of features. But we also want something that's not going to bring the humble laptop to its knees, because we can't assume that every learner out there is going to have access to parallel computing.
Cool. So that's everything so far. Go and have a go of the assignments. It's a good way to make sure you've understood the concepts. On behalf of Lewis, David and myself, would like to say thank you very much.